Atoms are the individual particles that make up all matter. At the center is a dense nucleus made up of protons and neutrons. Protons are positively charged particles and neutrons are neutral, or they carry a zero charge. Spinning around the nucleus in more of an electron cloud are these tiny particles called electrons, and each of these have a -1 charge. The electrons circle around the nucleus in three-dimensional shells, which are discrete energy levels. The first shell around the nucleus can hold up to 2 electrons only. And if present, the second and higher shells can hold up to 8 electrons. Now, if we look at the periodic table in a typical entry, say of fluorine in the periodic table, we'll see three basic units of information. One is the atomic number at the top, the element symbol, F for fluorine, and an atomic mass at the bottom. Now we're going to focus on the atomic number for now. And the atomic number is always the number of protons in the element. So when you see the atomic number, you know for sure that how many protons are in the nucleus of the atom. Now an atom is neutral when the number of protons equals the number of electrons. Thus, the number of positive charges equals the number of negative charges, and thus the atom would be neutral in that case. So what I want you to do is take a moment to see if you can figure out how many electrons a neutral atom of fluorine has surrounding its nucleus. Just push pause and take a minute now to figure that out. Okay, so how many electrons does a neutral atom of fluorine have surrounding its nucleus? First, you would look at the atomic number and find that it has 9 protons, thus has 9 positive charges. To balance those positive charges and be neutral, then it would have 9 electrons. So if you got 9 electrons, congratulations. Now when atoms interact with each other and ultimately bond with each other, the valence electrons become an important consideration. Valence electrons are the electrons that occur only in the outermost electron shell. So we've already calculated that neutral fluorine has 9 total electrons, but how many electrons are just in the outermost shell? How to go about figuring this out is to first draw an atomic model to picture it. Start with just the nucleus, represented as a black dot because our focus is going to be on the electron shells. And there's the first shell, which can hold up to 2 electrons at the most, and then there's the second shell. Now since we've already used up 2 of our 9 possible electrons, then we have 7 electrons left. And since the second shell can hold up to 8, those 7 will go there, meaning that neutral fluorine has 7 valence electrons. So again, I want you to press pause at the bottom of the screen and take a minute to draw atomic models for each of these neutral atoms, and then tell me how many valence electrons each of them have. For hydrogen, we see that its atomic number 1 and thus has 1 proton in its nucleus. Now to balance that 1 positive charge, this atom has 1 electron in its first shell, so hydrogen just has 1 valence electron. For nitrogen, we see it has 7 positive charges, so we would put 2 electrons in the first shell and the remaining 5 electrons in the second shell. So nitrogen has 5 valence electrons. Finally, for chlorine, we need to balance the 17 positive charges in its nucleus with 17 negatively charged electrons, so we put 2 electrons in the first shell, 8 electrons in the second shell, a total of 10 so far, and the remaining 7 electrons in a third shell. Chlorine then has 7 valence electrons.